all the stuff that we did in the intro activity and in 3.1 was all about moving left, right, up, and down. But you can have other things affecting a graph. Like, what happens if there's a negative in a graph? You saw that with x squared. What happened to your parabola if you put a negative out in front of your parabola? It made it open down, right? Okay? Now, for parabolas, we talked about opening up and opening down. Now we're going to take that same idea and generalize it for everything. What really happened to your parabola is it was reflected over the x-axis. It was flipped over the x-axis. And so we're going to say when you have a negative on the outside of your function, outside affects things vertically, we're going to call that a vertical reflection, because that would take that parabola and shift it down. Vertical stuff affects your y values. So if I had the point 8, 4 on my original graph, that point, when you flip it down and over, can you see that the x value would still be 8? Because vertical stuff affects y values. But now my y coordinate is a -4 instead of a +4. So not only are we going to look at graphically, this gets reflected over the x-axis to create my new graph, but algebraically, a specific point, the y value is going to change and become negative. And if you have a negative inside, and you never did this with parabolas, because what would happen if I put a negative inside and I squared it? Well, that, if you simplify that, wouldn't that just be the same as what you did or had originally? You just have x squared. So we never talked about this with parabolas because it's kind of redundant. It's like, ooh, take a parabola and reflect it over the y-axis, reflect it horizontally. Well, you end up with the same parabola. If we spent a whole lesson graphing the same thing by just putting a negative inside, you'd be like, that was kind of pointless. But other graphs, it makes a difference. Like this one here, if I took this original red graph and I put a negative, it would flip it over. And the point 8, 4, when flipped over, can you see it would go to the far side here? Because it's the same distance here to here. And now it would be at -8, so the x value would change, but my y value doesn't. So when the negative is inside the function, that's horizontal. So we're going to write that down as a little note. So the negative outside the function, sometimes it's written this way, sometimes they could put the negative with the y. And to describe that, so we say if that negative is outside the function, sometimes we say if the negative's with the y, because that's the second equation, then this is a vertical reflection. A vertical reflection is over the x-axis. And the y values get multiplied by -1. And the grade 12 course, as you write this down, likes to see if you can understand something from multiple perspectives. So what I mean by that is if they gave you the red graph and they said, could you find the graph, and they just gave you the function notation with the negative outside, could you recognize that that's a reflection over the y-axis? Sometimes they won't give you the function notation. Sometimes they'll just say, hey, could you do a vertical reflection? Sorry, over the x-axis, not the y-axis. Could you do a vertical reflection? Oh, then you would know you have to go over the x-axis. Or they could say, could you reflect over the x-axis? So all of those things describe how the overall thing is a reflection over the x-axis. Algebraically, all that's happening is your y values are getting multiplied by a -1. And the same thing, we can make a note for when the negative is inside the function. So when the negative is with the x inside the function, this is a horizontal reflection. That goes over the y-axis. And the x values get multiplied by -1. And there are so many little details designed to see if you're paying attention. Okay? Horizontal is pretty easy to think that it goes left and right. Your brain does pretty well with that. But when it says over the y-axis, it's almost like it's trying to play a trick on your brain. Because when it says over the y-axis, your brain says, hey, y? Y is vertical. And then you screw up. And I would say that at the end of the year, you will probably consider this unit one of the easiest units. But at the end of the year, if you look back at your test mark from this one, it's probably not going to be your best test mark. Even though you'll say it was the easiest, one of the easiest units, your test mark from this one might not be the best one, because your brain will play tricks on you. Like that left-right being opposite already, that's the x's being liars. Here you see reflect over the y-axis, and you do the wrong one. It's going to play tricks on you. So don't feel bad when you make you will make those mistakes. Hey, I don't know, you could, if you are watching the video again, I made the mistake already. Even in my explanation, because didn't I say I think I said over the wrong, I had to correct it. Like, it's so easy to make a mistake. And also some of these math things that we're doing, it's pretty easy to do. Take a graph and flip it over, you're gonna say, that's easy to do. So your brain, whenever you're doing easy things, sometimes takes oh, I'm doing something easy, I can take a break. Okay? And that's when you make mistakes. Right. Don't take breaks on easy things, don't take breaks going downstairs. Make sure your brain is concentrating, because if you miss a step, that's bad. Have you ever been going down steps and not been paying attention, and you're in the rhythm, like you've got it under control, but then you get to the bottom and think there's one more step? You ever done that? And then you go to step one more down and you hit the ground because it's more steps, and you do this weird kind of, because your brain's taking a break, right? So very easy in this unit to do that, to take a break. But here's our first example. Here's the graph of g of x. Sketch the image graph after reflection in the y-axis. So then I sometimes go, okay, if I'm reflecting in the y, I'm taking things, I'm going over this way. I actually do this with my hand. Okay, that's horizontal, right? I'm moving things left and right when I flip over the y. So when I see that, I think horizontal reflection. Okay? I might even think horizontally is with the x. Well, this is g. So that negative would be inside the function. So now I can take each point. This one's 3 away from my y-axis. It's going to be 3 away on that side. 1 away on that side. This one's 3 away. And this one's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Play or connect the dot. There's my graph. State the domain and range of each function. I'm going to do set notation again because we haven't done one like this in set notation. My smallest x value for my domain is -3. And my biggest x value is 5. So when we write in set notation and we are in between two values, we go -3 less than or equal to x less than or equal to 5, which is saying x is in between -3 and 5. Same thing for the range. My smallest y value is -2. And my biggest y value is +2. So my y is in between -2 and 2. For my blue graph, My domain is now minus 5 less than or equal to x less than or equal to 3. And my range is exactly the same. A couple of things I want you to notice, because a very typical thing to test understanding in grade 12, and they do it again in AP, is could you answer some questions if we took out some of the information? So for example, in this question, we asked domain and range after we had the graphs. So we got those domain and range by looking at the graphs. If I took away the graph, there we go. You can't see the graph anymore. But they told you the red domain. They said the original function had -3 to 5 and -2 to 2 for domain and range. And then they told you there was a reflection in the y-axis. What are the new domains and ranges? Could you come up with this without the graph? First of all, the range is easy because if it's a reflection in the y-axis, it's horizontal. Horizontal affects only the x's. Do you notice that our two ranges are the same? Because the y's were not affected. Algebraically, what happens when you reflect? Your x values are going to get multiplied by a -1. Can you see that the 5 became a -5? Can you see that the 3 became a +3, and it sort of took it and reflected it over in the domain as well? So that would be sort of a little bit harder of a question, because they took out some of the information and you had to understand how to come up with the answer with that information. All right, so questions, circle 3 and 13.